Lesson 6 of my AS induction programs is on quadratic equations, and we'll be looking at some factorizing now, and we're looking at quadratics for the next few lessons and the different skills that you can use for it. The starter would be backing up what we just did on straight lines over the last week. So please have a go at that if you missed the class. Sketch the lines and show where they meet algebraically, similar to the homework. In class I would have drawn them and showed you how to do it and shown you how to do it algebraically. But this is what we're going to do today. We're going to start with the B grade GCSE ones, where we try and factorise an x squared without a number in front of it. Then we'll go to some A grade ones, some special case ones, and finally we'll go to the A star ones with numbers in the front there and look at a couple of ways of doing those. It's a skill that's going to be incredibly important. I think if you think of 8 core 1 questions, probably 6 of them would involve a quadratic factorising at some stage. You want to get very good and very quick at these things. Whether you need any teaching for this, you might want to go back to a GCSE one, but I'd be looking at these I'm trying to think of 2 numbers at times together to give 12, and I'm thinking 3 times 4 makes 12. But when I add them together, that doesn't give the 8 I want. Oh look, it gives the 7, so that must be the 3 and 4. And in class, I'm sort of asking somebody else, do they know another times number that makes 12 on the end? And they're saying, I know 6 and 2. And of course, 6 and 2 would be that answer there. Are there any other times sums that make 12? Because I need another one down here. And this one here, of course, is 12 and 1. So 12 and 1 together make 13. And so I'll put those in there. And again, I've got yet another one here that makes 12. See how similar that is to that first one. I've got an 8 there, but this time it's negative. So this time, because both signs are going to have to be the same to make it plus on the end, I must be having minus 6 and minus 2 there. This really is a case of practice, practice, practice. There is a nice Excel sheet with loads and loads of these on to practice and with the answers appearing, but why not have a go at some of those there and see what you can do. It looks quite daunting, but 40 of them, but that's again from a GCSE book because it's such an important skill. Some of the special case ones are interesting. This one here, I always laugh when it's actually an easier one than the ones you've been doing, but because you're so used to going like this, you miss the fact that this one is actually just an x here. There's an x in that times by x, and there's 9 x's in that one there. So it's x times by x add 9, and we might also say something like 3y squared plus 27y. That one there is an easy one as well, because 9 goes into both of them, and there's a y, 9y times y, and 9y times 3. So look out for those. This one here has got its name called, it's a difference of 2 squares. Difference, because it's minus, and both of these two things are squared. And we use this in the surds work, that you get one thing plus and one thing minus, because look, x times x gives the x squared, 3 times minus 3 gives the minus 9, but in the middle there we've got 3 x's and minus 3 x's, which cancel out. So look out for those. They come up in many, many different places, a lot of those in core 4 as well, when we're doing some algebraic fractions. This one here has got no factors at all. I'd leave the class a while to try and see if they could factorise it. And some people might say x add 3 times by x add 3, and of course that wouldn't work because that would give us this one here. That would give us the 6x in the middle there. They might try 2 minuses. They'll try lots of different things until they find out it doesn't work at all. Here's some to try for yourself. All difference of 2 squares ones. And again, I'll make the class work through each of those because it is such an important skill. Before we now go into the ones that need more than 1x squared at the beginning. So these are A star at GCSE, and they're going to be the main diet of our AS level 1. To be honest, most people are most successful just by keeping guessing. And when you look at that one there, we're looking for 2 things at the start that times together to give 2. So we know it's got to be 2x and x. There's nothing else it can be. The same at the other end. There's just a prime number on the end there. So it's just a 2. So we know it's got to end in the 2 and the 1 because 2 times 1 is 2. If we did put it together like that, then we can now just see if it works. We've got 2x's from that part there and another 2x's from that part there. That would give us 4x's in the middle. That's not what we wanted. So the added bit that we have to try this time is maybe we have to swap them round. This time here, I've got 1x in the middle and 4x's around the outside. That does indeed give the 5x's that we wanted. So if they're nice prime numbers here and here, I really think guess, guess, and guess again. I mean, I had a fantastic student this year that used to write down each of the guesses, and she'd get it. I mean, it might take 5 or 6 goes, but she'd never get it wrong. So could you try these ones here? These nice 2s, that's got 7 and 1's nice one to do. 7 on the end there, you know it's got to be 7 and 1. The 4x, you might have to try 2x and 2x or 4x and 1. That's quite a nasty one with the 24 there, so many factors for that. But because it's got to end in a +1 and a +2, because that's the only thing that gives that, and then we're trying to get 19, or 19, trying to get 19 out of those. Trying to think what you could get in those ones there. Is it 8? I think it's 8 and 3, isn't it? 8 times 3 is 24. Look, there's 16, 17, 18, 19. 96 might be tough because there's so many different ones there. But try and factorize those. The other method, which really I didn't know when I was younger, but students taught me, was to find two numbers that multiply together to give 4. Now it's 4 because 2 times 2 makes 4. And they add together to give the 5, the same thing there. And so you're trying to think of, here we go, what multiply, I'll go back and do that one first. Let's get going with that. So can you think of two numbers that multiply to give 4? Well, it's 4 and 1, isn't it? 4 add 1 makes 5. 4 times 1 gives 4. And so what you do is you split this 5x up into 4x's add an x. And now you look at this in two separate parts. This part here is 2x, lots of x add 2. And this already is an x add 2. So there's 1 x add 2 there. And so altogether, you've got some x add 2s. You've got 2x of them here, and then an extra 1 of them there. So we've got 2x add 1, lots of x add 2. And there's the factorising complete. Here, you're trying to think of two numbers that multiply together to give 6, but they add together to give -7. And so what are we looking at there? 6 and 1, or -6 and -1. So we split this up into 3x squared minus 6x's minus x add 2. And now factorise this bit. What have we got here? We've got 3x's there, lots of x take away 2. Now this thing here can look like x take away 2 as well, can't it? It's just -1 of them. Look, -1 times x is minus x, -1 times -2 is +2. So we've got x take away 2's. How many of them? 3x take away 1 of them. 3x take away 1 of them. If you did write it round the other way, it works as well. So let's just write this round the other way. So we could write 3x squared take away x, take away 6x, add 2. And again, factorise that. We've got an x, lots of 3x take away 1. And can we get 3x take away 1 in that? Yeah, we can. It's -2 of them, isn't it? -2 times that is -6 plus 2. And look, we've got x take away 2, lots of 3x take away 1. Exactly the same answer, just in reverse. And I even did another one here. So we're timesing together to give 24, and we're adding together to give -10. So I think we're doing 12 and 2 here, aren't we? And they're both minus again, both minus here. So I've got 8x squared minus 12x's. No, it's not that, is it? It's plus. It's plus. That doesn't multiplying together to give 24 and add together to give minus 10. That's not right, is it? Let's just pause while I think about it. Oh, it's just the pressure of the video. I didn't see it. It's minus 6 and minus 4, isn't it? Didn't want to stop. Having been going for 10 minutes, you don't want to stop there on the last example. Minus 6 and minus 4. So we've got minus 6x minus 4x add 3. That works, doesn't it? And so we can factorize this thing here. We've got 2x going into that and 4x take away 3. And have we got something that looks like 4x take away 3 there? Yes, we have. We've got, again, got another minus 1 there. So I've got 2x take away 1, lots of 4x take away 3. I think as I've made a mistake there, it would be perhaps a good idea to check that we've got that right. Look, let's go with that one. 2x's times by 4x's is 8x squared. Good, I wanted 8x squared. Then I've got minus 4x's here and minus 6x's there. Well, that gives me minus 10x's, which is I wanted. Good. And then I've got minus 1 times minus 3, which is plus 3. Brilliant, I did get it right. Sorry about the little error. Some for you to factorize here then. Move that out of the way. Some for you to factorize there to practice. Oh look, difference of 2 squares ones there. And again, there's another Excel sheet with different ones to practice on too. Here's the answers to those. And we're going to look at the graphs as well. I think I'll leave that till next time when we actually look at some of the graphs of these things. So we'll stop there.